Number 7 says, a rock's thrown horizontally from a 100-meter high cliff, strikes the level ground 90 meters from the base of the cliff. At what speed was it thrown? So here's your cliff. Here's your mean little man throwing rocks. And the rock is going to travel like this. It's going to hit the ground. And your cliff is 100 meters high. And it lands 90 meters from where he threw it. And question was, what was the initial velocity of this? That's what we want to figure out. So his velocity is all horizontal because he's throwing it horizontal. And we want to know what that velocity is. So, make an X and Y chart. Now you're working in 2D. In the X direction, our change in X is 90 meters. What else do we know? That's about it for now. Oh, we know our acceleration in the X direction is 0 meters per second squared. There is no acceleration in the X direction. In the Y direction, our change in Y is 100 meters. Our acceleration is negative 9.8 meters per second squared. What else do we know? We know our initial velocity in the Y direction is 0. Okay, there's no vertical component to that rock that he's throwing. He throws it all horizontally. And what we want to do is we want to find time. One more thing to keep in mind. The rock's falling down, so technically that's negative 100 meters. How can we do it? Well, let's see. We could use this equation. Change in y is initial velocity times change in time plus 1/2 acceleration times change in time squared. Initial velocity is 0, so this whole thing is going to go away. So we don't have to solve a quadratic. So I get negative 100 equals half negative 9.8 delta t squared. Negative 100 equals negative 4.9 delta t squared. Delta t squared equals negative 100 divided by negative 4.9, 20.4. Last step, I've got to take the square root of each side. I get 4.5 seconds. Okay, so that's how much time it takes for the rock to go from here down to there. That's the total time in this problem. We don't have to double it or anything because we figured out how much time it takes to go from there down to there. It's not like he's throwing it up and then it falls back down. It's just falling. So we can take this and we can use this over here. So our change in time is 4.5 seconds. And I want to know, what's my initial velocity? Initial and final velocity are going to be the same because your acceleration is 0. Alright, so I'm going to use this equation, delta x. It's initial velocity times time plus 1/2 acceleration times time squared. Here's the cool thing. Since acceleration is 0, this whole part of the equation is going to go away. And you're left with a really easy equation. 90 equals VI times 4.5. Solve that for VI. And you get 90 divided by 4.5. You get 20 meters per second. Is that what's down as the answer? Yeah, 19.9. Yep, same deal. Cool.